Welcome to SameCon. My name is Buttars. Today we're going to be talking about hardening the LAMP stack. So who here has downloaded the VM already? Okay, cool. So I originally planned this to be kind of a hands-on, let's go through, secure it, but then I was thinking about it. By the time everyone got their VM set up and got everything working, it'd probably be done in an hour. So we're going to play Choose Your Own Presentation today. Who wants a basic overview as opposed to just drinking from the fire hose? So fire hose, raise your hand. Okay. And basic overview, raise your hand. All right, looks like the fire hose is going to win. So if you have any questions, we'll just go. I'm going to go really fast. If you have any questions, you can come talk to me later about it. I can go through kind of the basic setups. The presentation isn't in the presentation files because I rewrote this last night. So if you go to obscuritysystems.com, you can download the presentation and it'll give you a better view of what I'm talking about. Might be hard to read that. It's obscuritysystems.com. So a little bit about me. I'm a security researcher. It's kind of a hobby and a software developer. During the day, I'm a blue team. I like to secure systems and I like to hack systems. I like to play both teams. I'm a member of DC801. I've been working with those guys for the past 3 years, just doing some fun stuff. Part of the 801 Labs hackerspace. The hackerspace is kind of a facility for user groups like DC801. So if you're interested in doing some hacking, we'd love to have you come out and kind of hang out and work on some stuff. And also, I had the great opportunity to speak at DEF CON. I spoke at DEF CON 22 and 23. And I got my start here at SameCon. SameCon letting me present here, so I'm excited to be here. This has been a great conference and been great for my career. So there's plenty of opportunity for you guys out there. Take advantage of it. Additionally, I'm also part of a podcast, the Web Security Warriors podcast, if you're interested in hearing more about web security and other stuff. So, I take it everyone here knows what hardening is, right? We're going to secure systems. And the main thing that we need to think about is availability, right? If we have a secure system and it doesn't work, we have nothing. So I'm going to skip over this. You guys can kind of read that later. Web attacks. We have defacement, spamming, spreading malware, denial of service, injection flaws, application logic flaws, all kinds of cool stuff. So, Linux hardening. It's hardening the operating system. So we're going to drink from the fire hose today, and what we're going to learn today is that blue team is hard, right? We're going to go through all the little things that we need to do to secure a Linux system. So I was going to write my own guide, but I found a really good one here. I'm going to blow this up. So, what do we start with? So he starts with a basic install. I'm going to skip over the kickstarting part and just kind of talk about Manting Partitions. So one of the things you want to do when you're securing Linux systems, you want to divide all of the different applications, the logging, the operating system, and your application into different partitions. And the reason we do this is that if one of those gets full, it won't stop the operating system, it won't stop the logging, it won't stop the system from running. Additionally, you want to install NTP. We need NTP for logs so we can see when things are running and when they're not. Or, we need to know when something's happening. Additionally, AID. So, who knows what AID is? Okay, AID is an intrusion detection system. It's a very basic one. And what it does is it just takes an MD5 hash of all the critical file system files and creates an AID database. So when you do your AID init, you're going to want to take that AID file and store it off of the system, right? Because if someone gets onto your system and gets remote access, they can just do an AID init and reinitialize all of the intrusion detection database, and everything looks fine. Additionally, you want to prevent USB storage mounting. We're going to enable password security here with the auth config. So we go through all these settings. So we want to have strong password authentication. This is for our SSH system, or just basic logins in our PAMD system. We want to have maximum password attempts, and we just want to set it at 9 for failed password attempts. We want to limit password reuse, and then we want to verify. Looks like he's talking about verifying broad permissions, but so any questions so far? Am I going too fast, too slow? Grub require authentication for single user mode. So if we have physical access to the Linux system, we want to make sure that they have to enter a password. So this means that we can't change the password unless we unmount the image. If we lose the root password and we have to reset it, we'd have to unmount the image and go in and modify files and do things like that. Disable Control-Alt-Delete for reboot activation. So here, we're just going into this Control-Alt-Delete config file and redirecting it to just a log. So if someone presses Alt-Control-Delete, they can't reboot the system. Console screen logging. So now we get into the networking of the Linux. We want to disable IP version 6 if we're not using it, right? If you're not using something, turn it off. Enable the UMask 077, which basically what the UMask does is just every time you touch a file or do anything to a file, it sets the permissions. So by doing 077, we're telling globally that we're not going to do any, the global files and the group files can't do anything. Because the UMask is a subtraction of the permissions. So this would be 700 on files. Securing the cron. See this looks here. So syscontil has just basically all the kernel settings here. We want to disable IP forwarding. Who knows what IP forwarding does? Right? IP forwarding turns your Linux server into a router. So if it's enabled, that means we can connect to the system and I can route packets through it. I can use it as a router, use it as a network address translation, do all that thing. So we want to disable IP version 4 forwarding. Turn off send redirects, max send backlog, ignore broadcasts, all this good stuff here. Send cookies, you want to make sure that you have that in there to prevent DDoS attacks and things like that. Tcp wrappers are nice to basically block SSH connections. You want to have one quick, so going back to the kind of the quick thing to do, the first thing you want to install on a system is deny hosts. If you're just setting up a system and you want to get it up and running, I always install deny just yum apt-get or yum install deny host or apt-get install deny host. What that will do is it will install a monitoring system for your SSH process. So if someone's trying to brute force it or attack it, it'll add them to the deny host file. And so here what he's doing is he's just saying, hey, I'm denying everything and then just allowing SSH in the deny host file. And then deny host, the program will actually put the passwords, or not the passwords, the IP addresses of the brute force connections, or the IP addresses where the brute force of the SSH connections are coming into the deny host. And then you do have the problem of if you enter your password in too many times, it'll block you, so you can put your IP address and allow host. That kind of gives you some basic security for the SSH process. So, this is IP tables. So one thing he has here is the default drop policies for both input forward. He doesn't have accept. think here I've got a better version. IP table. So on CentOS 7, IP table isn't there by default. You've got to install it. They have Firewall D. I personally prefer IP tables over Firewall D. If you like Firewall D, you can use that. So if you're looking for a good guide on IP tables, this book is really great, this Linux Firewalls. But in his chapter 1 here, he has a basic IP tables template. Inside this template, he goes through and basically enables all the basic stuff and blocks all the incoming and outgoing. So one reason why you want to block outgoing, why would you want to block traffic leaving your server? Yep, it prevents data leaving your system. So we want to prevent, we want to limit what they have access to. If someone modifies or does something, you can kind of go back and see what's going on. You can see here we can remove a bunch of junk services. X and D, I'm not going to use Telnet, RSH server, TFT, Chrony, Bind. We leave it HTTP, we're actually going to be using that to make sure that we disable services that we don't need. Disable network filing systems we're not going to use. And then one thing I recommend doing is, if you can, limit your SSH connections from known sources. So just provide a list of places you know you're going to connect from your SSH server. And if you can't do that, you're like, well, I need to connect from a bunch of different places, installing deny hosts or fail to ban is a good option there. Turn off. So another thing you want to disable is you want to disable Dhcp. You don't want your system getting an IP address because there's ways, especially with the shell shock vulnerability that came out, there was a way that it manipulate the Dhcp requests and actually gain remote access onto a system. So, set static IP addresses and remove the Dhcp servers that will pull IP addresses and set a default IP address. We want to enable buffer protection by kernel exec shield 1. Make sure ALSR is in place. So ASLR is going to randomize the binary tables that the system loads up, so it makes it more difficult to execute exploits. So one thing that we need to stop doing is we need to stop turning off SE Linux. Talk about this a little bit more. So anytime you have an issue with SE Linux, you can do the set enforce 0 and set enforce 1. You can kind of play with it and see, am I having a problem with SE Linux? And if you are, you can use allow audit to allow, and I'll talk about it a little bit more later, to take your SE Linux issues. So you're saying, oh, here's all the problems that are having that are in the audit log. I'm going to make a policy out of that. And additionally, if you're trying to do something, there's probably already a policy in place that you can enable to do what you want to do with that system. So, moving forward, just securing SSH, we want to use protocol 2, limit users access, we're going to set an idle timeout. So this is important because if someone puts a backdoor in your system, they're using SSH to backdoor out, you want to make sure that time's out so that there's less surface area or it's less time for them to do something. They can't just let it sit idle. Disable root login. So if you have a Linux system, you don't want to log in as root, you want to log in as an unprivileged user and then sudo to root. CentOS by default, you usually set it up with a root username and password. As soon as you do that, you go into the system and again install sudo, and then disable root login, and then enable the wheel group in the vi sudo. And at that point, then you can just log in unprivileged users and still do root level administration. So that's the L part. We're going to move on to the Apache part. Okay. So, Apache should never be ran as root. We want to make sure that the Apache user is using no login bin, and we want to make sure that the file permissions are set correctly. So this is just kind of the basic things that should be set by default. If they get changed, you can go through and change them back. So right here, this is the secure default setting. So if you were to wipe out your Apache config, this is the most bare bones secure Apache configuration here, where we just have the directory, we have the options none, allow override none, and then we just tell it the directory. So all this does is host files, right? So the options directive, we allow options instead of, so we allow everything. Who here is using CGI? Nobody, right? So we just want to turn it off. Another thing we want to stop using with Apache is we don't want to use symlinks. We want to turn those off, and if you have to use them, you want to enable symlinks if owner matches, so that it'll only follow the symbolic links in the Linux system if the user is the same user, Apache user. To avoid using symlinks, just use mod alias. So if you have a directory where we have images and we want to store stuff there, we can tell it, hey, /images, just go to this directory. Another thing we want to stop using, if we can, is stop using htaccess files. I have more details in the slides here. But .htaccess files can allow override. If someone can get access to the file system or write to the file system, they can write htaccess files. And additionally, htaccess files will slow down your server. So it's much better to just have your config inside the Apache config instead of using the htaccess files to do your mod rewrite or do any of your configuration changes. The allow override directive basically controls what the .htaccess file can do. Here's just a list of how to configure it and how to do things like that. Again, if you don't need it, just turn it off. Additionally, one thing we want to do on our Apache system is we want to reduce the information leakage. So we don't want to broadcast to people that we're actually using Apache. So we want to do server signature off, server tokens production only, and set the server name. Common outs, yeah, server tokens. We want to turn trace off. Who here knows what trace does? So what trace is an HTTP, it's an HTTP protocol where I just basically say, I'm going to send you a request, and I want you to send back what I told you. What that's used for is debugging load balancers. So if the load balancer is modifying the header or doing something with my HTTP request, I can use the trace command to kind of say, okay, this is what I sent, and this is what the server responded back with. So if we're not doing load balance testing, we're not doing testing, we want to turn that off. So here we can use the curl command. We can see by default we get all this header information. Down below in green is the header information. So it's saying it's running Apache, it's sent to us. We get the time, date, all kinds of stuff here. So by turning these off, we can reduce our fingerprint. And then here with the curl-v command, you can look at your server's fingerprint and see what headers it's displaying back to the user. Additionally, we want to reject file types. So if you have a list of file types that you're using in your environment that you don't want served up by your web server, ideally like GIF files or .svn or something like that, we can create kind of a rejected file types. You don't want to put anything in here like docs, PDFs, or anything that, if you're not serving it, reject the file type, so that way you can kind of mitigate how much information leakage your system might be setting out. Turn off the default welcome. This is Apache, a lot of stuff that's in the Apache config here on this URI here, file path. So one thing you can do later on if you want to install mod security is you need to enable full server of tokens. So that kind of goes counterintuitive what I said before. Because mod security will actually let you modify the server signature. So here we can do something fun like telling the system, hey, we're actually Microsoft IIS 5. I like doing that because it's, you look at the headers and like, what? They're running way old Microsoft technology. It's kind of fun to do. So again, we go through, so like we did with the Linux operating system, we go through and we eliminate all the unneeded Apache modules. Here's just a few of them that I got rid of. Mod dav is kind of a critical one because if you're not using webdav, you guys familiar with webdav? What does that do? Let's communication in, out, lets you do write to the system, read from the system. You just turn that off, turn CGI off, remove these things. So when we're doing system hardening, we also have to make sure that we keep the application in mind too. So we make a change, go through, test it, make sure there's no errors, make sure nothing's actually using that. When we're done with everything, we want to go through and retest the application, make sure that the environment that it's running in is running well. And you might also want to have an unsecure system with the same application you can test to say, okay, the error that I'm seeing is actually from the security hardening, not from the application itself. So one thing that you hear a lot about when you're talking about hardening is rooting. And so this is kind of the process you want to shroot something. Environment with bash, make a shroot directory, we copy over all the files that it needs, and then we change our shroot directory to the shroot / run in bash, everything's great. You can use strace too to identify potential problems if you're shrooting. So one thing that they talk about is like, oh, you should shroot Apache, right? Well, here's all of the files and everything you need to do to shroot Apache. It's kind of complicated, lots of stuff can go wrong. Additionally, I don't kind of believe in shrooting anymore. I feel that's kind of like an old way of kind of protecting an operating system. I think it's a little bit more work than you're probably going to get benefit. Additionally, there's been a ton of research done on breaking out shroot trails, and so it's kind of considered insecure. But it's one of those things, there's additional layer of security you can add if you feel like you're up to it. It's kind of an introductory guide on how to do that. So we talked about SE Linux before. We want to stop disabling SE Linux because that's your first go-to. It's like, oh, nothing's working, I got to get it working, I just want to get moving on. So instead of disabling SE Linux, what you need to do is just figure out why SE Linux isn't working correctly. And so, in a lab system, all you really need to do to get Apache talking to the MySQL database through SE Linux is just enable the HTTP CAN network connect to DB. And at that point, you've got network connectivity to the database. And then you go through and restore con. That will restore the configuration. So if you make changes to the var www.html directory, it'll restore the SE Linux file permissions and go through and make it so that it can manage all the files and apply that correctly. You also want to install the policy core utils for Python that will let you troubleshoot a lot of the SE Linux issues you're going to run into. And then you can yum install the troubleshooting SE tools too. Additionally, those have a lot of great utilities, and there's some guide here below. And if you're looking for specific, already predefined SE Linux policies, you want to run get sepal -a, and that'll list all of the predefined policies, and you can grep through HTTP, and that'll give you a list of all of the HTTP policies. So if you want to enable memcache or anything else, there might be a policy, and you just go through and enable it, and you're good to go. And so before I was talking about audit to allow is pretty cool. First, you want to make sure that your SE policies are up to date, so you just do that, command at the top. And then audit to allow, there's a guide here, and basically what it'll do is it'll show you, here's all the things you were trying to do in your audit log, and here's why it failed. And then audit to allow, like, okay, so I ran through my SE Linux problems, I tried to do everything I wanted to do, and then you use audit to allow, and it'll build a policy out of that, and then you can take that policy and say, hey, here's the things I want the system to do, and then apply it. So that way you can still have the SE Linux protection and still do what you want to do. So additionally, I take it, you always want to, if you're talking about web security, you're going to be talking about TLS, SSL is dead. This basically goes through how you can generate a self-signed certificate. If you're doing anything public, you want to have a PKI, you want to have it signed by a third party. But one thing that kind of gets missed over a lot is the Ssl configuration. And so you'll see a lot of times that SSL will be not configured properly. So additionally, now that SSL is dead, we only want to use TLS. We want to configure our TLS configuration with this setup here. And this is a secure setup that passed the SSL Labs test. So if you want to test your SSL configuration on your Apache server, you can go to sslabs.com. They'll run a scan. You want to make sure that you don't publish the results, especially if it's on a public server that you're setting up for the first time. That way you can get the scan and it's not published to the public in case you misconfigured something. And with these settings, you should get a A+ pass. The IRC4 there is there just for legacy. So if you want to support Internet Explorer 6, you can enable the RC4. It is kind of insecure. But what we have here on the top is we have the SSL honor cipher order. So what that does is the server is going to say, I'm going to try and use the most secure cipher that I can first, and we can see that RC4 is at the end there. So it's like if I have to go all the way down to RC4, I will. And then you can look at your SSL configuration settings by using OpenSSL S client, your host domain, the port. And that'll give you kind of a printout of what SSL is seeing and what protocols it's using. Additionally, you always want to fail safe. So if you have a secure system, you want to make sure that if something breaks, that it breaks securely, right? We don't want to fail open. So if our security system's not working correctly, we would tell it to block something instead of letting something pass. So if you're not using port 80, don't run an Apache. So this is an example of a denial of a service attack on Apache. Oh, plenty of time. So here you can kind of run some SYN flood attacks, and then you can do temporary fixes. So if someone's attacking your server with DDoS, you can run this IP tables command, and it'll drop their IP address for 60 seconds after they've hit a 20 count. Then you can filter for SYN flood packets. It's kind of useful. So additionally, there's a SYN flood, and what SYN flood does is basically just takes all the open connections, so it sends a SYN packet, doesn't send the, we send back the ACK, we don't send back the SYN ACK, we just keep SYN. If you're doing, if you're under attack, like a distributed denial of service attack or reflection DDoS attack, you probably need something more robust to kind of take care of that. So one tool that you can kind of use to prevent DDoS attacks is Modevasive. Modevasive is kind of cool. You install Modevasive, and then we use our SE Linux policy. So if we're under a DDoS attack or someone's trying to send a lot of traffic to our server, we can send an email out to ourselves and say, hey, this is happening. So we set up the notification email, we load the module, and then we define the settings here. So page count site count, page intervals, blocking period. So we want to block them for 10 seconds. We have all the configuration here, so if we want more detail on what all those options do and how to configure them. Here's a Modevasive script that I pulled from this link here, and it will go through and block someone trying to DDoS your web server in IP tables on your system. And then we want to modify the server file so that Apache can actually run this command. So that's what we're doing here. There's a bunch of settings here. We can fine-tune the DDoS, timeouts, keep alive, keep requests, configuration limits. We want to configure the limit of the body field, the body request, the body, the headers, all kinds of good stuff here. Skip over this. The NPM settings are basically how Apache forks. So here you can kind of fine-tune it. Part of your security, you want to identify how much traffic you're going through, how many threads, how many forks you want to do, limited processes, max clients at any given time, things like that you want to go through and configure. And this you want to do based off of your application and your traffic. Make sure you have logging enabled for Apache, and actually look at your Apache logs. They're actually very interesting. You can see all the places people are connecting to, you can see what popular places are on the application, and you can also see what people are looking for that's not there. So if someone's attacking your website, they might be looking for PHP MyAdmin or WordPress or a bunch of other stuff, and so you can see a bunch of weird requests for things that don't exist on your system that you shouldn't see there, and through that you can go through and be like, okay, I probably should just block this IP address because he's not using my application the way I want him to. Or he's just trying to look for malicious ways to manipulate my application or do something to my system. So who here has heard of a web application firewall? Okay. How many of you have set up a web application firewall? Okay, good. So Mod Security is a free, open source web application firewall, and it is very powerful. Like, I've been exploring a lot of its features, and today we're just going to talk about basic setup. But I do recommend if you have the free time, go through it, learn it, know it. It can help save you a lot of headache and help you, really secure your web application. I'm actually quite impressed with its capabilities and the things you can do with it. So, on your web application, on the VM, you've got Mod Security installed. You just want to load the Mod Security modules, create a directory for the rules, and then tell it where the rules are, and then download the rules. So we can go through, download a bunch of rules off of the Spider Labs, set the configuration. And so here's kind of the important part. So we're going to tell it set rule engine on. So what this means is that the web application firewall is on and it's blocking. And if there's malicious traffic, it's going to send back a 403. That's how you know it's working. So if you WAF, but you don't want to block traffic, what you're going to want to do is turn it into detection mode only, right? So you install the WAF, you install Mod Security on Apache, and then you put it in detection mode. And through detection mode, you have to go through the error log and say, okay, this rule actually applies, this rule doesn't. This was legitimate traffic from a customer, I don't want to block the traffic. And then once you're happy with your rule set and you're happy everything's in place, then you enable it, and then you want to make sure that you watch it too. So when you're available when you enable it, so that if someone does have an issue, because it does have metrics in there, so if it sees enough anomalies that look like an attack, it will block a user. I can guarantee that your WAF, or anytime you have a detection method, you're going to catch your customers more often than you're going to catch your bad guys. So definitely spend some time on Mod Security. It's a great tool. I highly recommend it. Any web application you're setting up or any Apache system, make sure that you have it set up and configured correctly. And even if you don't, working environment, like we don't want to block anything, put it in detection mode, right? So if you have a WAF set up and it's in detection mode and you have a compromise, you can go back to the log and say, hey, well, we didn't block this attack, but we definitely saw their signatures and all of their attack methods, and you can kind of piece back together what happened and build a better security architecture. All right. We did the L, we did the A, and now we're on to the P. We're getting through this. Luckily, the MySQL, there's not a whole lot to do to secure it, because it's kind of hidden away anyway, so we're good to go. So securing PHP. So in the PHP UNI file, we want to disable exposed PHP. We want to turn that off because why? Well, we don't want to tell people we're using PHP. We have the .php extension. You might want to, change that to use URLs that don't expose that. But by default, just turn off the exposing of PHP so that way, someone trying to attack your system has to kind of guess at what's going on. Disable errors. We don't want to display errors to the users. If there's something wrong with the application, we just want it to silently crash, display no errors. We also want to log all errors. So if we're seeing a lot of errors in the PHP application, we want to make sure we're logging all of that. If we don't need file uploads, turn it off. If we do, turn it on. We want to limit the upload size. So an attacker, when they hack your application, they're going to look for file uploads because they're going to want to upload their malicious content or their backdoor or something. So if we limit the amount of data that they can transmit in the upload, we can make it more difficult for them to use your application or your web server maliciously. So another thing that we want to do is we want to disable allow URL open off and allow URL include. That is off by default, but this is one thing you definitely want to check on your web server, because if that's enabled, then the attacker can remotely include PHP scripts and execute those scripts from your server. So that's something you definitely want to check on a compromised system or any new system, is just to make sure that's turned off. Max post size. We want to turn safe SQL mode on. Yeah, I think that's a typo. I think it's SQL safe. I'll have to go look at my notes again. But basically, SQL safe mode just tells the application, has the application use proper parameterization when it connects to the MySQL database. Turn the safe mode on, turn GUIDs. We want to disable globals, enable DLF, DL off, I forgot what that was. What? It's not a typo? Okay. SQL.save, that's weird. Everything's all underscored. Cool. Remember the deal. There's a reason to turn that off, and I keep forgetting it because it's so obscure. SQL, the SQL safe mode? Okay. Yeah, that's probably okay. We want to turn globals off. Globals can cause security issues. Some applications might need it, so that's another thing you want to test. Disable functions, I'll have a list of those. So we want to define the upload directory. We want to do this because we only want uploads in a certain directory, and so that's a place we can look for potential malicious scripts or anything like that. Error reporting, we want to report everything, but we want to disable displaying that to the user. So this is a PHP. Files so that the developer doesn't, you don't have to worry about the developer's code. And it's cookie.secure means that the cookie information will only be set over SSL HTTP connections and won't be sent out through HTTP connections. So if I understand correctly, if you don't set the cookie to be secure, even when you're going to other sites, they can still read the cookie, right? Mm-hmm. Yeah. So without it, they can do an HTTP downplay request, downgrade attack, where they can convince the server to remove the SSL and transmit the cookie in clear text. Is what Nate's repeating. I'm repeating what Nate said. Is that correct? So this is a list of some dangerous PHP functions. One thing you can do in your web application is go through and look for these. So you just do a grep space -ir star, and then just look for the name and see if they're actually being used. If you're not using them, disable them. I have PHP info in there. Just turn that off, because how many times have you ever really used PHP info for anything other than just setting up, right? So this is one of those things that's going to be, you have to do customly. Don't just take this and copy and paste it and say I'm good to go, because you might need some of these functions, but some of them are just things that you don't want to run, like exec and like shell exec. Like if you're not doing any command line stuff, your application doesn't have to have access to the shell, don't use them, turn them off. They can be very dangerous. Unneeded. So you can check permissions on unneeded PHP modules. So if you do PHP space -m, it'll give you a list of all the modules that are installed. And the modules are installed in sephp.ie, and then you can just kind of rename them to disable. So like here, I'm not using SQLite, so just go ahead and disable it. Additionally, there's a kind of a cool project I was looking at, which is PHP IDS. I think if you're using mod security, you probably don't need PHP IDS, but it's kind of a fun thing to play with because it has a bunch of signatures and other things that are specific to PHP that'll block attacks. So that's kind of the PHP configuration. Any questions? Okay. Cool. So if MySQL is just a bunch of don'ts. Don't allow accounts outside of root to access the user table. So for every application that we have in our MySQL database, we need to have a user name and password for that. And that username and password needs to have permissions that are specific to that application. And most of the time, all you're going to need is select, insert, and update, right? What applications really shouldn't be using delete. If you're writing a web application, you shouldn't be using delete. You should just be, if a user says, oh, I want to delete this thing from item, you should just mark it as hidden. If you have an application that is using delete, you will have to enable it. But if you're writing an application, just try and not use the delete command. It's a good thing to just kind of get out of the habit of using, because it can be kind of dangerous if that SQL injection gets hijacked, because they can manipulate it to delete data. And most of the time, we have huge hard drives, we have huge amount of data collections, there's no reason to really delete any data. And knowing users, most of the time you delete something, they're probably going to want it back anyway. So additionally, one thing that you want to do is make sure MySQL is kept behind a firewall at all times. Don't expose it to the local network. Don't expose it to clients that don't need access to it. Your database contains all of your data. We want to expose MySQL. If we do, we want to encrypt the traffic. We'll show that with Tunnel. We don't want to store MySQL passwords in clear text. You can use PHP libraries or something else to kind of fix that. you're running an application that has passwords and clear text, you might want to go in there and fix it or do something with it, or basically, just don't do that. And MySQL shouldn't trust any data that's entered by users, so your application should be filtering the input. Never run MySQL as root. Never do that, because if MySQL gets compromised, it has file write features, and it'll have full access to your system. It'll be able to get your password files and all kinds of other things. Don't permit to use symlinks to tables. Use IP addresses instead of host names, because host names can be faked with DNS. Unless you really trust your DNS, but for the most part, if you're doing your grant permissions, just use the IP address. Additionally, don't specify passwords in the command line. So when you're connecting to the server, don't type your password, what's the command, because it's saved in the MySQL history. So this is Stunnel. An Stunnel is a utility you can use to encrypt your MySQL traffic. So if you have a web application server on one system and then you have a MySQL server on another system, you can stand up Stunnel, and Stunnel will create an SSL connection between the application server and the database server. And this will do is it will prevent if there's any sniffing or one of your servers get compromised, it can't sit there and sniff all of the traffic that's happening off the web server to the database server. And it kind of prevents other types of connections and attacks that you have to have a valid certificate to connect into the Stunnel. So here's the basic configuration. We've disabled Ssl version 2 and version 3, so we're using TLS. We tell it to listen to incoming connections on local port 3306, and then we reroute 3306 to 10.0.0.1.3307, which is the MySQL server. And then this is the MySQL server config. We have the SSL certificate and all the configuration. We're not using SSL version 3 or 2, we're using TLS, and we're telling you, okay, any inbound connection on 3307 is going to connect back to 3306, and then this way our web application doesn't have to know where any of this SSL configuration, MySQL doesn't have to know any of SSL configuration, it just goes through and connects and everything's good. So when you're running a MySQL system for the first time, you want to run MySQL secure, and just answer yes to all, set the root password, delete the test database, remove all of the default username and passwords on that system, and remove all of the remove the users that have blank passwords. And MySQL Secure will kind of go through that and remove all of that junk for you and give you a secure setup. Additionally, in the MyNI security file, we tell it we want to bind to localhost, especially if we're using Stunnel. So that way we can guarantee that it's not going to be exposed on the network. We want to enable the log file so that if someone runs malicious queries, we can go back and look at them and see what happened. We want to disable local infile, so what that does is it disables the MySQL functions that allow you to write to files and load files from the operating system. So again, here we have just a basic create user. We set the permissions. We have select, update, delete, on, database, flush the privileges. We can see what privileges that user has. We can revoke. So just kind of a template. So if you want to see what information is going by in clear text on your queries, you can run TCP dump here and listen on port 336 and just run it through strings. You got to be careful about that because strings can be exploited too. But that will just kind of give you a view of all of the traffic that's going in between your web server and your database server. Additionally, who knew about the MySQL history file? Right? This is a treasure trove of what's happening on your system. There's usually a ton of passwords in there. So you're granting passwords, granting privileges. You want to clear that, and then if you're not really using it, just disable it. So disable, we're going to link dev null to MySQL history, so any MySQL history that gets recorded is going directly to null. We're not recording any of that stuff. And that pretty much covers it. Question? you talking about encrypting the data in the database or encrypting like the file system? For encryption, that's kind of like a complicated topic, because that's something usually the app developers should be doing. So the app developers should be encrypting their data and storing it encrypted. If you have data that's being stored encrypted, you should keep, what I do for my stuff is I have a public key, so I'm using OpenSSL libraries and PHP, and I have a public key. So my web servers have the public key on them, and I keep the private key stored somewhere else. And so when I have data come in that needs to be encrypted, it comes in, it loads the public key, encrypts it, and it's stored in the database encrypted in a text file. And then when I need that data, I decrypt it using a private key that I store somewhere else. And so I have a web application interface where I'll put that private key and I'll store that private key in memory and then go through and decrypt the database. You can also encrypt on the file system too, but you're going to lose performance with that too. That goes back to kind of Linux hardening. If you want to encrypt your data, but if you have sensitive data like social security numbers, credit card data, you should be encrypting it, and you should be using a public key infrastructure, not using a symmetric infrastructure. So if you have, if you have the key, you don't want to be able to. Your web server shouldn't be able to decrypt data. It's kind of the way it should be, because your web servers at some point will get compromised. Does that answer the question? Or is there something specific? You had another question? Oh, sorry. It is root and syncon 2015. And it's just a basic install of CentOS. You can go through and go try all these things and play with it.